Hello class ninth. We are back with the next part of the chapter number 3, that is atoms and molecules. In the previous chapters we have learned about the atom, the laws of chemical combinations, Dalton atomic theory, its drawbacks and the symbols that is given by the J.J. Berzelius as well as the Dalton. Then we also know about the elements, atomicity, molecules, ions, chemical formula. Now we have to proceed it with the how to write a chemical formula. I have already told you to write a chemical formula, we must know the thing that its symbol plus its valency. Symbols, we already know that is given by the different scientists, especially the J.J. Berzelius. We are using that symbols, and for the valency, it is the combining capacity of an element to bind with the other element to form a compound. So generally the charge on an ion will represent its valency, whether it is a negative charge or a positive charge, or how much electron it is sharing with the other, it is also known as its valency. Now there are some rules before learn how to write the chemical formula. We should know the rules. First rule is the valency on the ions must be balanced. The valence should be balanced by the other ion, other element, other atom. If we are talking about the metals and non-metals, the substances which are present in a compound, it is always be there that metal name should be written firstly, then the non-metal name. For example, sodium chloride, NaCl. Na is the atom and Cl, chlorine, is the non-metal. Na is the metal. In case of polyatomic ions, if the ions which are having more than one atom in there and they're having a charge, so that it is considered to be the polyatomic ions, like CO3 2 negative, SO4 2 negative. These are the polyatomic ions having two different atoms involved in it, but overall having the charge over them. So we should always write the numbers in the bracket if we are using them in any chemical reaction. So for writing a chemical formula, we must know how to write it. Firstly, we should remember the name and the symbols of the matter, any element. For example, MgCl, they have taken the MgCl, so that the name is magnesium chloride. If we need to write the symbol for the magnesium chloride, then the symbol of magnesium is Mg and the chloride will represent the chlorine, so symbol is the Cl. Then we need to write their valencies. Mg valency is +2 and chlorine valency is -1. So after writing the valency, that means the magnesium required 2 atoms and the chlorine required only 1 atom to complete its octet state, to complete its stable state. So for that, what we need to do to write it completely, we need to exchange its valency. Chlorine valency should be written down towards the magnesium and magnesium valency should be written downwards the chlorine. So after writing this, what we'll get? We will get Mg1Cl2. So we can omit the 1 here. The final formula will become MgCl2. Similarly, we need to know the valency of each element, each atom, each ion, and then we can easily write the formula. Similarly, we have the different formulas written over here. Sodium oxide, sodium is Na, oxide is oxygen, valency of sodium is +1, valency of oxygen is -2. We'll cross it and we'll get the formula as the Na2O. Here, one thing that we need to figure out, if we are talking about the magnesium hydroxide, means the polyatomic ions. So magnesium, that is the one Mg, polyatomic ion is OH, whose overall charge is -1. So what we need to do, we need to write their charges or the valency, that is +2 is for the magnesium and the 1 for the hydroxide. Then we cross check it. So what we gonna do, we were gonna add it. So OH is required completely. OH, the polyatomic ion, is required. That's why we need to put the brackets and write the number of atoms of hydroxide that is involved in making the formula, that is MgOH2. This is how we can write it. Similarly, there are some numerical problems that we can discuss here. So the first one is the valency of carbon is 4 and that of chlorine is 1. The valency is already given. We need to write the formula for the carbon tetrachloride. So carbon chloride 4 1, exchange the valencies, CCl4, 1 can be omit, so CCl4. Carbon tetra means 4 chloride, so this will be the formula. In the second next problem, valency of the element X is given, X valency is given as 1 and that of oxygen is given as 2. So X is the one element and oxygen is the another, valency is 1 and oxygen is 2. So formula, we'll like cross check the valencies, so will become X2O1 and we can omit the 1, so the answer will be X2O. So formula of compound of element X with oxygen is X2O, which will represent the water in it. So this is all about how can we write the chemical formula. So till now we have discovered that how can we write a chemical formula by just knowing the numbers, by just knowing the name of the any formula, any substance. So now let's learn more about the valency of the different ions, monovalent ions, divalent ions, polyatomic ions. Monovalent cations, cations which are having the positive charge. So monovalent ions, those are having +1, 1 plus as their valency, so they are considered to be the monovalent cations. For example, hydrogen ion, lithium ion, sodium Na plus, potassium ion K plus, ammonium, this is a polyatomic ion, NH4 positive, silver Ag plus, copper Cu plus. Copper first is there, if their name is cuprous, then it is considered to be the having the +1 valency, and similarly first is written here. Why 1 or 2 is written here in their name, we'll learn more about it, because they are showing more than one valency, that's why their name has been written with the first and second thing. Divalent cations which having as 2 plus as its valency, magnesium Mg2 plus, calcium Ca2 plus, barium Ba2 plus, copper Cu2 plus, zinc Zn plus. Here you can see this copper is seconded, is written here, the valency is 2 and the name is given as the cupric. Similarly for the mercuric, Hg2 plus having the valency as 2. So iron, it is having the Fe2 plus. Now the monovalent anions. Anions means which are having the negative charge over them. Monovalent having, mono means single, so they are having the -1 as their valency. So the examples are hydride ion, fluoride, chloride, bromide, iodide, nitrite, it is a polyatomic ion, nitrate NO3 negative, it is a polyatomic again, hydroxide OH negative, hydrogen carbonate HCO3 negative. Now divalent anions, these are oxide ions 2 negative, sulfide ions 2 negative, sulfite ion, this is the polyatomic ion SO3 2 negative, sulfate ion SO4 2 negative, carbonate ion CO3 2 negative. Similarly, trivalent nitride ion N3 negative, phosphide ion P3 negative, phosphate ion PO4 3 negative. Similarly, we are having the trivalent cation also, that is aluminium Al3 positive. And Fe also, ferric ion, that is Fe3 positive. Ferrous, if we write ferrous and we need to show it, we'll write 3 in the brackets to show its valency. Now what is the significance of the formula of a substance? Significance that it represents the name of the substance, first point. It also represents the molecule of the substance, molecule of the compound that we have learned now. So the formula also represents the molecule of the substance. Or again, it is also gives all the elements that is involved in the forming a particular compound plus the number of atoms that is required to make that particular compound. Plus it also describing the 1 mole of the molecule, that is equal to 6.022 into 10 raised to the power 23. It gives the definite mass of the substance. This is the main important significance of the formula of any substance. We are going to learn more about the masses and how can we calculate the mole, how can we calculate the gram atomic mass of a particular substance in our next video. Till then, take care and have a good day.